Okay, well, I have received a request to do a couple of examples regarding the quadratic formula. Okay, well, here is a video explaining a couple of examples of how to use the quadratic formula to be able to solve a quadratic equation. Now, the first thing that's very important is that you have to put the quadratic equation into standard form. That means that you set it equal to 0, okay? And once you've done that, then you need to identify what is the value of A, what is the value of B. Now, I'm sorry, A is the coefficient of your quadratic term, B will be the coefficient of your linear term, and then C will be your constant. And then once you've identified those three values, then you're going to substitute it into the quadratic formula and you will find your solution. Now, your solutions might be rational numbers or they might be irrational numbers. Okay, so let's do an example together. We add a new page here. So let us look at example number 11 in your textbook, and that is 7x squared plus 2x minus 2 equals 0. Now we know this is a quadratic equation, and the reason why I know that is because the variable with the greatest degree is x squared, so an equation that is squared is quadratic. And then we have three methods we know to solve now. We could either use a zero product property if it's factorable. We could use completing the square, so we would rewrite it so it's a perfect square, and then solve. And this technique will work on any equation, quadratic equation, or we could use the formula. Now, since we're practicing the formula, that's what we're going to use today. Now, make sure you write down the formula each time so that you can memorize it. So remember, it's the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay? Got a little rhythm going there. So we know that a in this example is the coefficient of the x squared, so a is equal to 7. B is the coefficient of the linear term, 2. And then c is the constant, negative 2. And I take those values and I substitute it into the formula. So it's the opposite of b, so it's negative 2, plus or minus square root of b squared, so it's going to be 2 squared, minus 4ac times 7 times negative 2, all over 2a, and a is 7. You must show all of this work. You can't just skip steps here, folks. Now, order of operations says I must simplify within this radical first. So I get 4, and then a negative times a negative is a positive. 4 times 7 is 28, times 2 is 56. Can you hear that? My pizza's done. All over 14. So we get negative 2 plus or minus the square root of 60 all over 14. Now, I think I can simplify this a little bit. 60, let's look at the radical 60. Is there a factor of 60 that's a perfect square? Well, I'm thinking 4 goes into 60. Isn't it 4 times, let's see, 60 divided by 4 goes in once, 20, leaves me a 15. Okay, so then I could rewrite this as negative 2 plus or minus, so radical 4 is 2 radical 15 all over 14. Now, can I reduce this? I can only reduce it if every single term can be divided by the same factor. So you notice here is a term, and here's a term. Do they all have a common factor? Yes, they do. They can all be divided by 2. So then I would end up with the result as negative 1, 2 divided by 2, negative 2 divided by 2 is that, plus or minus a radical 15 all over 7. So that would be the answer for number 11. Let me go take that pizza out of the oven and then we'll do one more example together. Okay, now that I've had a piece of pizza, I can finish this off. So here we have another quadratic equation, and I can tell that it's quadratic because the term with the greatest degree is squared. So remember, with the quadratic equation, there's 3 different ways we've learned to solve these. First of all, we could try to factor it and use the zero product property. We could try the completing the square method. And then last of all, we could do the formula, okay? Now, completing the square and the formula will always work on every quadratic equation. But sometimes completing the square is just a lot of work, and the formula is more efficient. However, if I can factor, many times zero product property is a more efficient method. But all that to say, since we are learning about the quadratic formula, we are going to use the quadratic formula. Now remember, with the quadratic formula, you have to rewrite the quadratic equation into standard form, and then we're going to use the formula, the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay, so in this problem, let's see, the value, first we have to rewrite it in standard form. Don't identify your a, b, and c until you've set the equation equal to 0. Now identify your a, b, and c. That's where a lot of mistakes are made, folks. So a, the coefficient of the quadratic term is 4. The coefficient of the linear term is negative 12. And the constant is 7. So using those values, let's solve for this variable y. So y will equal the opposite of b. So the opposite of negative 12 is positive 12. Plus or minus square root of b squared. So negative 12 squared minus 4ac all over 2a. Remember the all over, okay? So 12 plus or minus. Now, according to order of operations, I must simplify within the radical first. So negative 12 squared is 144, and it's a negative, 28 times 4. I'm going to have to do a little work right here. 28 times 4, 2, carry the 3, 8 plus 3 is 112. Okay, all over. Why didn't I substitute the a in? 2 times 4 will be 8. Now what's 144 minus 112? Again, I gotta kind of do this. 4 minus 2 is 2, 4 minus 1 is 3, so I get 32. So I get 12 plus or minus radical 32 all over 8. Now remember, this numerator is a binomial, and with binomials you can only simplify it if every single term has a common factor. So don't think because you see a 12 and because you see an 8 you can just reduce by 4. Every term has to be 4. And you can't just divide out the 4 from 32 because it's a radical 32, not a rational number 32. So, first thing we need to do is see if radical 32 has a factor that's a perfect square. And we know it does, right? 16 times 2? Heck yeah. So what's the square root of 16? Well, it's 4. So 4 radical 2 all over 8. Now when I look at this problem, I can see that we have, when we look at the 3 terms here, 12, 4, and 8, all of them can be divided by 4. So when I divide 12 by 4, I get 3. 4 divided by 4 is 1, so 1 radical 2. And then 8 divided by 4 is 2. So those are my two solutions. If I wanted to separate them, it would be 3 plus radical 2 all over 2, and 3 minus radical 2 all over 2. Okay, that's it for tonight, folks. Hope that helped.